Okay, so in this video we will be checking out my brand new 4790K, which I recently obtained. I actually traded CPUs with another user on HW forums, and this very particular 4790K looks very good based on initial tests on air and water cooling. So the 4790K and the Devil's Canyon CPUs, they are pretty much the same as the original Haswell. No big difference whatsoever when it comes to actual performance testing and overclocking. The only real visible difference between a 4790K and the original Haswell 4770K is for example in tests like Cinebench, the 4790K will easily give that error pop-up screen the test has failed and so on, whereas the original Haswell 4770K, it either passes the test like Cinebench or it will give a blue screen. So in that regard, I really like the original Haswell CPUs more because they are more consistent to bench. They don't give those weird error messages that easily, and I think the 4790K gives that error screen a bit too easily. It might even pass the test, but it just gives that Cinebench has failed screen and it will just exit the test. So that's the main difference between the two, but otherwise when it comes to overclocking, they are pretty much the same. There are some very good 4790K CPUs out there, at least for air and water cooling, and this is one of them, at least based on initial tests. So this particular 4790K has already been deleted. I am using Thermal Grizzly conductor now between the CPU die and the IHS. So I am still using the original IHS. I am not running direct die, as I don't have the adequate frame to run direct die, but this should be good enough. Although I'm not 100% sure about the actual mount, because the original glue was removed from the CPU's PCB and the IHS easily twiggles or it moves when I try to clamp the CPU down to the socket. So just saying. So the actual mount could vary a little bit. So just saying. And I'm using KPX thermal paste between the IHS and the CPU water block. The motherboard is the famous ASRock Z97 OC formula with the L1.12D BIOS, which you can see on the screen right now. It's my favorite board for Haswell and Z97 LGA 1150 overclocking, and it's the only motherboard for that platform and socket that I have at the moment. The memory is 2x4 GB G.Skill Trident X, 2600 MHz with 10, 12, 12, 31 command rate 2 timings by default, but of course we can run them higher if we want to. The memory kit is good for 2800 MHz plus with 9, 12, 12, 21 command rate 1 timings, and even CAS 8 at 2860 MHz if I give some cool temperatures to the memory sticks. If the memory sticks are cooled down to -60 or so, they can do CAS 8 at well beyond 2800 MHz. Simple Galax graphics card and so on, and 2000 watt power supply. But yeah, so let's get going. So we can enter the BIOS by pressing F2 or delete key on our keyboard. So here's the initial screen, so the BIOS version, which I already said. I think this BIOS version is one of the best you can get for this board, so no need to mess around with the BIOS version too much. So 4790K, the Devil's Canyon CPU lineup was released in 2014. This particular 4790K is a Vietnamese chip from 2015, so it's one of the later ones. The memory sticks refer to 1600 MHz by default, although the JEDEC standard of DDR3 is 3033. So we go to the OC Tweaker tab for all the overclocking settings. We go to the user OC profile, and I will load my bin profile. So we will be aiming straight for 5 GHz on the core and 4.5 on the cache. Cache is not so important when it comes to overclocking on these Haswell and Devil's Canyon CPUs. The actual cache of the CPU is the third most important factor when it comes to gaining more performance. The most important one is the CPU core speed, the second one is the memory, and the third one is the cache. And actually quite often I don't even try to max out the cache completely, because it's not very important at all. So 50, so all cores, we will try to run a multiplier of 50 across all of the 4 cores. 4.5 on the cache multiplier. An important setting for stability is the internal PLL overvoltage, which is already enabled in this profile. Then I think these are the speed step power limitation settings, so I always max these out. So 4000 watts, that is the maximum value you can set. Maximum long duration maintained setting, so 56 seconds, and maximum on these as well. So 4000 watts and 1000 watts. Yeah, they might sound a bit high, but it doesn't really matter. Then when it comes to memory, we will set this. I will set the default multiplier of this particular memory kit, so 2600 megahertz. Performance mode is enabled. Don't mind about the power chip profile setting. This particular profile that I'm running at the moment is recycled from another BIOS profile. So 10, 12, 12, 31, but command rate 1. So command rate 1 instead of 2. And all of the subtimings I have left auto for this initial testing. Then we max out the FIVR settings, so the switch frequency has been increased, and this is the switching frequency offset. Maximum value is 1.5. Is it plus 50%? I'm not fully sure how this works. Then I will disable the integrated VR faults and the efficiency mode of the FIVR. Extreme voltage mode is not enabled. That's only needed for like LN2 overclocking and so on. So CPU vCore voltage mode is set to override, aka fixed mode, because we want to set that ourselves. And look, 1.26 volts. Yes, you heard me correctly. 1.26 volts for 5 GHz or all-core CPU overclock. That's pretty crazy. I personally have a lot of experience with Haswell overclocking. I personally had one of the best 4770K CPUs in the world for multi-threaded benchmarking. That CPU was able to do 6.4 GHz in Cinebench on LN2, 6.513 GHz in GPU Pi 1 billion, which was also the record score, but I failed to take the validation file, and it also did well beyond 6.6 GHz in HWPOC Prime, which also uses all cores and threads. And that particular CPU, that was very old batch 4770K, and it was able to do 5 GHz in Cinebench with 1.285 or 1.29 volts before deleting. And I think after deleting, the vCore requirement dropped to like 1.27 or 1.26. I'm pretty sure it did require at least 1.25 volts for 5 GHz Cinebench even after deleting. But so far, this particular CPU is very, very close to that dead 4770K in 5 GHz CPU, in 5 GHz Cinebench voltage requirement. Many of these CPUs, even if they can run 5 GHz Cinebench with very nice voltage, they don't scale that much higher on water cooling. When I look at my old results with the 4770K, I was never able to run 5.2 GHz in Cinebench on water cooling, on normal water cooling I mean. So we don't talk about chillers and so on. So ambient restricted water cooling. Like the maximum speed I ever ran for like 3D Mark 06 and so on was only like 5.1 or 5.15. Never 5.2 for the CPU part of the test. So just saying. So if you have a very golden 4770K or 4790K, do not expect to hit frequencies of, let's say, 5.2, 5.3, 5.4 on water cooling. After like 5.1, when you go to voltage levels like 1.35 and beyond, you need to drop the temperature a lot more to remain stable. So the temperature starts to be the limiting factor up to 1.35 volts rather than the voltage itself. But yeah, so 1.26 for 5 GHz Cinebench, let's try that. Cache voltage is separate compared to CPUs of today. So cache voltage is separate, and it can actually be run it can be run at higher levels than the actual vehicle. The cache voltage doesn't really affect temperatures that much, but I would set this to something like 1.3, 1.35 for starters. Very few Haswell and Devil's Canyon CPUs will hit 5 GHz on the cache on water cooling, especially like 24/7 stable. For simple single core tests, you can often run 5 GHz on the cache with some CPUs, but many CPUs might only do like 4.5. Like many of those anniversary Pentiums, the cheap €50 Pentiums, many of them really struggle to do over 4.5, like over 4.5, 4.6, so just saying. So let's try with 4.5 and 1.325 volts. The IMC and IO voltages are controlled as in offsets on this particular platform. So the stock IMC voltage is 0.8 volts. That's actually very, very low value. So 0.8. And we want to get this to like 1.2 volts. So I'm setting 0.4 increase using this offset. And same thing goes for the VTT or the IO voltages. I want to get these to like 1.2. So I'm setting 0.2 on both of these over here. Then the input voltage is the only voltage that the CPU receives from the motherboard. All of these other voltages are separated inside the CPU in the FIVR. So the input voltage has to be higher than all of the other voltages that the CPU is getting. The stock voltage or the stock input voltage is something like 1.8. Well, this one is reading 1.744, so like 1.75, 1.8. Usually you don't need more than 1.9 on air or water cooling. You might be able to, you might try to play around with this voltage between like 1.7 to 2.1, but do not set more than 2.1. And one of the main differences between the early Haswells and Devil's Canyon CPUs is that the early Haswells really liked higher input voltage more than the Devil's Canyon CPUs. With many of those old Haswells, like the one that I had, many of them actually scaled with very, very high input voltage, like 2.6, 2.7, 2.8 on LN2. And when it comes to a Devil's Canyon CPU, 2.6 can be an instant death. So it's very dangerous to go very, very high on the input voltage on some of these CPUs. So when it comes to Devil's Canyon overclocking, like 4790K, G3258, I wouldn't put more than 2.4 on the input voltage on LN2. Unless you have really tried everything else. Like if there's nothing else you can try, then you might try to go a bit higher on the input voltage. But if it doesn't scale, if you do like small increments and it doesn't scale, it's very likely you will gain nothing if you go even higher in it. If you go even higher on the input voltage. So be careful when you mess around with this input voltage. But yes, you have to run it in fixed mode as well. So if you want to set a static value, load line calibration setting for the input voltage, level 1 is the highest setting. So you can see it over here on the right hand side of the screen. So level 1 is the static, like stable setting. So no voltage drop when load is applied on the CPU. Switching frequency, we want to max this out, so 1000 kilohertz or 1 megahertz. Memory voltage is close to the stock value of the XMP profile, so 1.65 or 1.68. Maximum switching frequency of 1.8 megahertz. These you can leave at auto pretty much. I often just set them manually to near the stock value, but you don't have to. It actually happened on this particular motherboard. When I left these values at auto, the Z97 OC formula actually set, I think it was the PCH 1.05 volt voltage or the ICC voltage to like 1.2 to 1.5 on its own when it was left at auto. And after that I have always left these near the stock value like manually, but it doesn't really matter. So we can just double check the settings, and yeah, for this particular testing purpose I have disabled like onboard audio and LAN and so on. But now let's go to the operating system and let's see how this will actually run. But this kind of frequency aim, or this kind of frequency target, is crazy high when talking about Haswell CPUs. So F10, save and exit. Okay, so server 2012, it's loading. So let's open up CPU-Z to quickly verify the settings we dialed in. So 4790K, 1.26 volts, 5 GHz across all of the 4 cores, 8 threads, Z97 OC formula with the already mentioned BIOS version, 4.5 on the cache, 8 gigs of memory, 2600 MHz, 10, 12, 12, 31 common array 1 timings. And this is the SPD profile of this particular memory kit if you are interested in that. So let's now open up Core Temp. I really like to stick to these older tests like Cinebench R15 because these are the tests we ran back in those days, like in 2014, 2013, 2015. So in order to be able to compare these results to the old results of those days, it's better to stick to these older tests. So these are the idle temperatures, they look very, very good. Let's fire this up. 52, 50, 53, 50, 45. There's some variation because the 4th core is only at 47 max, 2nd core 55. So the actual clamping process can actually vary quite a lot. So when you clamp down the CPU when you use the socket mechanism to lock the CPU down, the IHS moves easily because the glue has been removed from the CPU's PCB. That is why I prefer not to remove the original glue. The CPU doesn't really... Oh! So this is the very annoying error screen. These Devil's Canyon 4790K CPUs really trigger easily. This doesn't happen that much on 4770K, so if this was a 4770K, it's very likely the test would have passed. So it's very, very annoying, especially especially on LN2 as well. There, this particular error screen really pops up easily, and it doesn't really happen. It doesn't really happen that much with the newer platforms. Newer CPU generations after Devil's Canyon. So let's try again. But it was very, very on the edge, or it was pretty much passing. I just don't get why it crashed. But yeah, so far based on this result, this particular 4790K is very on par with the with my old 4770K that is now dead. I'm still a bit sad that I actually lost that particular CPU. It was just truly awesome. Yeah, 54, 56, 51, 47. So 1027 points, not very good result, but anyway it's still passed. So let's save this result and let's try to push more. So it's very on the edge. Maybe the minimum value, maybe the minimum vCore for this particular core speed would be 1.25 volts. That's how I feel. So it's very, very good, but again, the actual LN2 test will reveal on how good this CPU actually is, because it really depends on what's the maximum temperature this particular CPU can hit. Some CPUs cannot go colder than -90, whereas some CPUs might be able to go as low as like -140. The absolute best 4770Ks could go near -140. My dead 4770K could hit a temperature of like 138, 139. So somewhere around that. And of course it then depends on, does it actually scale? So does the particular CPU gain from the colder temperatures? So yeah, so that's the saved result. We could quickly try 1.25 volts, but it's very likely that it's going to fail. So let's drop the vCore down to 1.25. But yeah, looks damn awesome. 1.25 for 5 GHz Cinebench is very damn low. So let's try this. Let's try without Core Temp. but it's skewed. Yeah, it's because this is a recycled operating system from Z490 testing, so it's not like 100% reliable. Yeah. Oh yeah, well, doesn't really matter. So let's, as we could run 5 GHz at 1.26 volts, we could now try 5.1. But really it gets harder after 5 GHz, trust me. So let's open Formula Drive again. This is the software for overclocking when running ASRock motherboard. So this is the light version of this particular software. So let's increase VCO up to like, let's increase to 1.32 or from 1.33 and 5.1. Let's try this one. So back to normal. And run. So 58, 60, 54, and it crashed. Now I really don't like the Devil's Canyon CPUs because these are very dodgy. They easily trigger those error pop-ups compared to other CPU generations. The IMC of this particular CPU does seem alright, so now I passed 5 GHz again at the same voltage, and now the memories are at 2800 MHz, 9, 12, 12, 21, TRFC of 128 and command rate 1. So pretty spot on, 1.25 system agent and 1.22 I think on the IO. So let's save this up. But really that 5.1 should have passed. It should have passed at 1.33 because I do have a screenshot of that run, so I can actually check. Sadly, this particular stripped down OS doesn't have the it cannot open these as it doesn't have paint, but we can actually try to look at them by setting them as background. It might sound a bit stupid, but so here's a 5 GHz run with 4.8 on the cache. So here's a 5.1 GHz run at 1.33 volts. Max temperatures have been 62, 64, 59, 52. So pretty much what it should be. But 5.2 is instant failure no matter what vehicle, and we can actually try that later. I did try the cache, and it's able to run at 4.9 GHz with 1.375 on the cache voltage. I should have another screen over here. So here you can see the voltages. So 5 GHz on the core, 4.9 on the cache, and the XMP level memories. Input was 1.95, vCore 1.32, and cache voltage 1.375. So 5 GHz might be able to pass if we increase cache voltage 1.45. But really, from like daily perspective, that is quite high value already. So if I was using this for daily use, I would leave the cache at like 4.5 or 4.6 because it doesn't affect the actual performance that much. So let's put the original background back and let's try 5.1 again, just to check like the temperatures and so on. So let's open that up and let's go to Formula Drive, open core temp. So let's increase this to 1.345. It should be more solid. 5.1. $59, $62, $57, $51. Temperatures aren't really of an issue, but these CPUs are just quite dodgy. And really it is just because of this particular CPU family. It gets so much harder to maintain stable overclocks after like 5 GHz and 1.25 volts or 1.3 volts. But you can already note that even as this failed, so 1.345 volts for 5.1, you can easily like make an assumption that 5.2 will not pass no matter what VCore value we will set. Beyond this point, the only way to get more stable or to get higher overclocks is to lower the temperatures. So let's try 5.1 for one more time. Also, it should make things harder because I'm running very high memories. Sometimes it's a bit harder to run both a very high overclock on the CPU and a very high memory configuration, but for some reason this is very picky now. Because really these temperatures are good. 62, 63, 58, 52, 134 watts power consumption or load. So yeah, so 1058 points in Cinebench R15, but required a bit too high voltage than it should require, so 1.355 in this example. But as we are running very high memory configuration, it's not that bad really. We can quickly try. I just want to show you that even if we set like 1.45, 1.5 volts on the VCore, because the temperatures do allow it, it will not make the CPU any more stable to run one notch higher multiplier, so 5.2 GHz on the CPU. But we can try that just to show you. So let's open Formula Drive once again. Just double check that it doesn't set anything weird on its own. Let's set 1.47552. I just want to show you. This will be an instant failure in this test, trust me. Just look at the temperatures as well. Yep, as you can see, and it's a blue screen, so it doesn't really matter at all. You cannot go beyond the 1.35 volt limit on these CPUs. You just need to get colder temperatures from beyond this point. Okay, so as last thing in this testing video, we could try to run 5 GHz cache in Cinebench, but really it doesn't really matter from like a normal use perspective, which I already said, but for testing purposes we could try. But one thing of note, you should never try to run cache higher than the actual core itself. Most of the time it's not even possible to run the cache higher than the actual core speed. But at least on X99 CPUs like Haswell E, you can actually run cache higher than the actual core with some specific motherboards like X99 SoC Champion, Rampage 5 Extreme and so on. So let's increase the cache voltage to 4.9 required 1.375. Let's increase the cache voltage to 1.45 in this example. Memories are still at 2800 plus, or at 2800 with Cas9. So let's set that. 48, 50. But this might fail. But doesn't really matter, that this is the end of this testing anyways. And it hang. So 4.9 is the max cache speed for this CPU on water cooling for multi-threaded tests. Okay, so I think that's pretty much it. I was not able to run 5 GHz or 5.1 GHz in Cinebench with significantly lower VCore by disabling the hyperthreading, nor by dropping the core count from 4 to 2. When I dropped the core count to 2 instead of 4, I was able to see 5.4 GHz in CPU-Z by increasing the VCore up to 1.45 to 1.5 volts. So I think that's pretty damn good. Now the biggest question mark is that how well the CPU can actually run on LN2. The top scores at the moment are made at like 6.25 to 6.3 plus when talking about like multi-threaded tests. So in order to have any chance to beat those, this CPU has to be able to go down to like -130 to -140 and to actually scale from those cold temperatures. Many of these CPUs, they might be able to run very cold temperatures, but then they don't really scale that much, if at all, from those colder temperatures. So I will have to see about that later. But will be very interesting anyways, because so far this CPU is very on par with my old and now dead 4770K that was absolutely golden for multi-threaded tests, at least based on these water cooling results. So let me know what you think. Do you like to watch these older like flagship CPU models being overclocked to really high values even on water cooling? Many people are still running these CPUs even in their daily systems today in 2020. So I think this kind of content should please many viewers, but just saying. So let me know what you think. Share your own experience and opinion down in the comment section down below, like what was your max frequency with 4790K or 4770K, and what kind of frequencies you were able to run in Cinebench or in a daily situation. But yeah, so thanks for watching this video once again, and I will see you on the next one.